Welcome to ECO 301, Intermediate Microeconomic Theories. In this lecture, we explore optimization techniques. Optimization simply means finding the best possible outcome under given limits. Linear programming, or LP, is the mathematical tool we use to do this. It helps us maximize or minimize an objective, such as utility, cost, or profit, while respecting constraints like income, budget, or resources. LP is widely applied in economics, business, and policy analysis to guide rational decision-making. Consumers aim to maximize satisfaction from goods and services given limited income. The utility function, often expressed in Cobb-Douglas form, represents preferences. For example, U of x and y equals x raised to alpha times y raised to beta. The constraint is the budget line, P sub x times x plus P sub y times with less than or equal to income. Linear programming helps determine the optimal combination of goods that gives the highest utility within the budget. Consider a Lagos household with 10,000 naira to spend. Rice costs 500 naira per derica and yam costs 1,000 naira per choba. The utility function is U of x and y equals x to the power of 0.5 times that to the power of 0.5. The LP problem is to maximize utility subject to 500 x plus 1,000 less than or equal to 10,000. Solving this, the household spends 5,000 naira on rice and 5,000 naira on yam, buying 10 dericas of rice and 5 tubers of yam. This shows how families allocate scarce income optimally. Producers face a similar challenge, maximizing profit given resource constraints. The profit function is pi equals PQ minus C of Q, where PQ is revenue and C of Q is cost. Profit equals total revenue minus total cost. Firms earn revenue by selling output at price P and incur costs to produce it. Their goal is to choose the output level Q that maximizes profit. Imagine a bakery in Benin City. Bread sells for 200 naira per loaf. Producing 1,000 loaves costs 150,000 naira, giving revenue of 200,000 naira and profit of 50,000 naira. This simple equation, pi equals PQ minus C of Q, captures the essence of producer optimization, balancing revenue and cost to achieve maximum profit. Optimization matters for everyone. For firms, it guides production decisions, how much to produce or whether to expand. For policymakers, it explains how cost changes affect profitability. For students, it connects theory to real business operations. Resource limits such as labor and raw materials define the constraints firms must manage. Let us model the bakery's production mathematically. It uses flour, denoted F, and labor, denoted L. The production function is Q equals 2F plus 3L. Constraints are F less than or equal to 100 kilograms and L less than or equal to 50 hours. The objective is to maximize bread output. The LP problem is maximize Q equals 2F plus 3L subject to those constraints. Using all flour and labor gives the maximum output. Here is how this appears in an exam. You will be asked to formulate the optimization problem, solve for optimal F and L, compute maximum output, interpret the result, and as a bonus, calculate profit if prices and cost are given. This tests your ability to apply linear programming to real production planning. Step 1, define the problem. Maximize Q equals 2F plus 3L, with F less than or equal to 100 and L less than or equal to 50. Step 2, identify objective and constraints. Step 3, apply constraints. Use all resources. Step 4, compute Q equals 2 times 100 plus 3 times 50, which equals 350. Step 5. Interpret full resource use gives maximum output. Step 6. Profit extension. Substitute prices and costs to find 35,000 naira profit. The bakery achieves efficiency by fully utilizing its resources. Linear programming is about maximizing satisfaction or profit under constraints. Consumers face budget limits. Producers face resource limits. In Nigeria, inflation and scarcity make these optimization problems real and constant. LP provides a systematic way to find the best possible choice given limited means. Consumers maximize utility subject to a budget constraint. The Lagrangian method helps solve this mathematically. L equals U of X and Y plus lambda times income minus P sub X times X minus P sub Y times Y. The result is the Marshallian demand function, showing how much of each good is bought at given prices and income. With 10,000 naira income, rice at 500 naira and yam at 1,000 naira, utility is U equals X to the power of 0.5 times Y to the power of 0.5. The optimal choice split income equally, 5,000 naira on rice and 5,000 naira on yam, giving 10 rice and 5 yam. This demonstrates how constrained optimization explains everyday trade-offs Nigerian families make when prices change. A household with 5,000 naira faces prices of 500 naira for gari and 1,000 naira for beans. Utility is U equals X to the power of 0.5 times e to the power of 0.5. The LP problem is to maximize U subject to 500 plus 1,000 less than or equal to 5,000. The solution allocates half the budget to each, 5 gari and 2.5 beans. This shows how LP helps households choose the best mix of goods under tight budgets. Firms maximize profit subject to production constraints. Using the Lagrangian approach, pi equals PQ minus C of Q subject to resource limits. The result is the optimal output level given cost and technology. For example, at the bakery again, maximize Q equals 2F plus 3L subject to F less than or equal to 100 and L less than or equal to 50. The form uses all flour and labor to reach maximum bread output. Now, an agricultural case. A cassava farmer in Edo State has 10 hectares of land and 100 hours of labor. The production function is Q equals 5L plus 10H. Constraints are L less than or equal to 100 and H less than or equal to 10. Plugging in maximum values gives Q equals 600. The farmer's optimal plan is to use all land and labor. If labor drops to 50 hours, output falls to 350 units. This shows how resource scarcity directly affects production. Linear programming helps farmers decide how much cassava to plant given land and labor limits. It also guides agribusiness and policymakers in designing fertilizer or mechanization subsidies. Extending to profit. Cassava price is 100 naira per unit. Fertilizer costs 200 naira per kilogram and land costs 500 naira per hectare. The profit function is pi equals 100G Q minus 200F plus 500H. Substituting Q equals 50H plus 2F gives pi equals 4,500H. With H equal to 20, profit is 90,000 naira. The farmer achieves maximum profit by fully using land. Optimization has real-world implications. For households, it explains how inflation forces trade-offs between staples. For firms, it guides production planning when resources are scarce. For policymakers, it helps design efficient subsidies and resource allocation programs. For students, it bridges mathematics and economics, showing how theory solves real problems. Linear programming and constraint optimization are universal tools. Consumers face budget limits, while producers face resource limits. In Nigeria, these techniques explain household food choices during inflation, firm production decisions under scarcity, and government policies on subsidies and resource allocation. Optimization is not abstract. It is the mathematics behind everyday economic survival and policy design. As you move forward in this course, remember that optimization connects theory with practice. It is how economics becomes a tool for solving real-world problems. In summary, optimization techniques, whether through linear programming or the Lagrangian method, help us understand how rational decisions are made under constraints. They show the balance between desire and limitation, between what we want and what we can afford or produce. From Lagos households managing food budgets to Benin bakeries planning production and Edo farmers maximizing cassava yields, optimization is everywhere. Thank you for engaging with this lecture. In our next session,